Hi, I'm Mark. Over the last 2 to 3 years, I have been researching, building, coding, testing, learning, and have created the solar-powered autonomous rover that you see today. Now it's ready for its final mission. It has been placed in a remote exposed mine to survive as long as it possibly can, completely off solar energy and no human interaction. But before we get to that, we need to go back 3 years to where it all began. As a young child, I was quite interested in space. I was particularly interested in the Curiosity rover navigating the Red Planet, and after doing some research, I set out to do something for myself. The prototype consisted of an RC tank I stole from my brother with some electronics taped to the body. I did this to test the core electronics and software before I was to move on to my actual build. This is the prototype just being driven with an RC controller, and here are a couple photos of it with the autopilot electronics, which enable it to do self-driving. After some testing and tuning in mission planner software, I managed to get the prototype functioning and self-driving a set GPS course by itself. From there, I moved on from my prototype to my full-size rover build. I did some research and ordered a ton of different parts and components. Once they finally arrived after many months of COVID shipping delays, I assembled the rover with drilling, cutting, screwing, bending, gluing, designing, 3D printing, soldering, and assembling. One important thing was to make sure to connect the motors on each side in parallel. A quick explanation is that when the motors are wired in parallel, the wheels that are getting more grip with the ground, in this scenario being the two outer wheels, will be drawing more power over the middle wheel, and the rover will be getting better overall traction and less power will be wasted. The opposite goes for wiring in series. They both have their use cases, but wiring in parallel would be better for my rover. With the hardware side done, I then have to code in the script and software for my rover. This script is in charge of managing the battery voltage, taking photos, changing the driving modes, powering the rover on with the use of relays, and powering the rover down into its deep sleep. Each hour, the rover automatically powers on and runs the script as the first thing it does. For me to consider my mission successful, it has to be run completely remotely, just like NASA has to with their rovers. I've set my rover up so that I can do pretty much everything from home base, with no interaction with the rover in person. First off, I can view all the images that my rover takes, every minute coming in on a web server I set up. This can be useful to look at what the rover is doing currently, and also look at what it's done already, being useful for troubleshooting and solving problems. Secondly, I have access to a PDZ or hand tilt zoom camera, which is basically just a camera that can move on a gimbal. And to top it off, it came with night vision and lights. This allows me to look all around the environment and the rover, to assess possible damage or just observe the surroundings. This camera became more important than I was expecting, as it has a microphone along with the lights and night vision, which can help me listen into the surroundings and the rover itself. And finally, and probably the most important thing I can do from home, is use Mission Planner. This software on my laptop can let me change crucial settings on the rover's self-driving, set or change the navigation course, view all the rover data like GPS location, the artificial horizon, rover speed, battery voltage, and if worst comes to worst, I can take manual control. On Mission Planner, I've set up this Xbox controller so that I can basically drive the rover like an RC tank with the live feed from the PDZ camera, all from the comfort of my own home. With that out of the way, I was ready for my rover's real-world test. I will leave my rover over at a remote mine for it to run laps around a section of the mine for as long as it possibly can, completely off solar energy and no help on site, with everything being done remotely from home, before it eventually cannot drive any longer. Speaking of which, a massive thanks to everyone at OceanaGold Macraes mine for letting me use this section of their mine for my testing. They were really helpful and friendly, and I'm very grateful for them letting me run my mission for as long as I went. There is a link to their website in the description. After driving out to the mine and setting the rover off, soon after an issue became apparent. My rover suddenly stopped driving. After taking manual control of my Xbox controller from home, I was able to move the rover after many attempts.
Okay, now we'll look to my left to see if there's like a mark on the ground or something.
As the rover limps away from the spot it's been stuck, I noticed some skid marks on the ground, leading me to think that something could be stuck in the wheels or something had broken. It was very difficult for my rover to drive, so I called the first missions in there. After another long drive to pick up the broken rover and some testing, I found that the motors were not functioning as they should. After opening up the gearboxes on the motors, I found one of the worst things. Inside the gearboxes were metal filings from the worm drive. If you are unfamiliar with how a worm drive works, you can see it here. Here on the right, you can see an unaffected motor and gearbox with little to no metal filings and a non-worn worm drive. This is what it should look like. But on the affected motor on the left, which is one that went to the mine, You can see all the metal filings and how worn the worm drive is, causing it to skip steps under load. This explains why the rover was stuck, the marks on the ground, and why the test ended the way it did. After some consideration as to what I should do next, I ordered some new motors for Attempt 2. They just barely fit the rover, but it's worth it as these motors have a lot chunkier gears and should hold up better to the relentless stress they'll be put under. Then we drove out and went to Attempt 2. Then Attempt 3, then 4, and 5 months had passed with no better results. I learned lots from my tests and fixed lots of problems like bolts coming loose and short-circuiting the motors together. This was fixed with Loctite and spring washers. The drive shafts that were slipping loose. This was fixed with fiber grip, which increases friction between surfaces. And that one attempt where I forgot to set the rover to wake up hourly, where I just had to click on one checkbox, and I was finally, after all this work, ready to see how long my rover could really survive all by itself. Now would be a good time to tell you about the sponsor of this video. Myself. At the release of this video, I have a total of 0 subscribers. Leave your mark and prove that you're one of the first supporters of the channel by giving a like and sub. After the long drive out to the mine for like the millionth time, I released the rover into its remote and exposed environment. After making sure that my Python script, the PDZ camera, and then the manual driving with my Xbox controller is working to make sure we don't have to restart this mission again, I shut the rover down for the rest of the day and ready it for its long mission ahead of it tomorrow. It's officially day 1 of the mission, and after connecting to the rover I can see it's driving already at 11 AM. From home on my computer I was viewing all the photos on the rover's web server and all the other rover data coming across the 4G network to make sure nothing went wrong. Over the day, my rover slowly crawled across the surface of the mine, and thankfully did so successfully. Day 1 was complete. It ended up travelling almost 2 kilometers a day over the course of 8 hours. And before I knew it, it was day 2 of the mission. But then, after logging onto the PTZ camera, unfortunately, I noticed something bad. I can hear how windy it is, and at some points, I could see the rover shaking in the wind. Keep in mind that my whole rover weighs about 16.1 kg. This made me start to keep a close eye on the forecast, and on really windy days, I would manually turn the rover's back directly into the wind from home base and temporarily disable its automatic driving. On day 2, we ended up clocking in approximately 668 meters, making our total 2.65 kilometers. Days 3, 4, 5, 6, and 7 followed suit, and the rover had completed its first week with no help at the side of the mine, with everything being done remotely. At this point, I was already satisfied with my rover. I'd already achieved my 2 main goals, which were surviving a week and generating more solar energy than used while driving. As you can see, getting up to 61 watts in tests. For the first week, we covered some serious distance at 12.1 kilometers for a rover that travels at crawling pace. Every day for week 2, I was logging onto my rover expecting some dumb issue to arise, but it never did. I was honestly blown away that it had lasted this long, greatly outlasting all my other tests, with no issues aside from the occasional windy day that I would remotely turn the rover's back directly into the wind. For week 2, it covered approximately 12.2 kilometers, making the total around 24.3 kilometers. Before I knew it, we were powering through week 3 and week 4 with no problems, and it had almost done about 14.3 kilometers these 2 weeks, making the total around 39.2 kilometers. I honestly felt on top of the world until the last day of week 4, day 28 came. We all knew it was coming. Day 28, the failure of the rover. You can see from the time-lapse that the rover is static and isn't moving. I was unaware that there was a problem with my rover at the time, as I had checked one photo and it seemed fine, whereas I should have checked a handful to make sure it was actually moving. The rover was constantly taking photos well into the night, thinking it was moving when it wasn't, until it eventually ran out of power at 3 AM. I caught onto this issue early in the morning of day 29, and did lots of testing and couldn't figure out what caused the problem. But what I did know is that miraculously, it had fixed itself. When it ran out of power, shut down, turned back on when the sun came back, it was already driving like nothing happened. This means it must be a software or firmware issue, as it could be fixed by a reboot. Because of this, I decided I would not try and diagnose further and possibly fix the issue, as trying to change things and push an update to the gutless onboard computer could be very risky in the middle of a mission, and it's not like rebooting the rover every now and again is a big deal. After this, week 5 was thankfully uneventful with no issues as we continued to add to our total distance, travelling around 9.4 kilometers, making the total around 48.7 kilometers. Week 6 came in on day 37. I was forced to reboot the rover with the same issue I was experiencing before. Then on day 41 of week 6, I decided to take the PTZ camera out once again and take a look at the rover and its surroundings. The wind was still not letting up, but but the rover seemed to be in good condition. As the sun sets, I disconnect from the rover to leave it to continue its relentless mission tomorrow. On week 6, the rover travelled about 5.2 kilometers, making the total a massive 54 kilometers. At this point, I thought the rover may have been able to survive a whole nother week. How wrong I was. Coming into week 7, day 43 was good, and then day 44 came, and I had to do a reboot as usual, but it never recovered like the other 2 times. I had tried the typical reboot and expected the rover to work, but it never did. I tried everything, taking manual control of my Xbox controller, using the motor test functions in Mission Planner, checking the servo outputs, listening in for the noise of the motors, observing the battery voltage as it attempts to move, but I could still not get the rover to move at all.
Did?
Yeah. My best guess as to what caused this is that it could have been an electrical issue, like a bad wire connection or something like that, as I could see the servo outputs were working, yet the rover wasn't attempting it. There were no movements. I did so much to make sure this wouldn't happen, with Loctite and spring washers, while properly tightening and fastening everything. But I mean, over a month of endless vibrations from driving, and powerful winds, and all it takes is one bolt to loosen, and one wire to vibrate to a bad connection, and here we are. So unfortunately, day 43 was officially my rover's last day driving, and took my rover's final distance to around 55.4 kilometers, which was well over what I expected from my rover, and I was extremely pleased with the end result. If you guys want to see a full unedited time-lapse, it's in the card in the top right. My biggest mistake was that I decided to leave the rover there like a sitting duck for too long before I went to go collect it, because I didn't realize that Mother Nature would bite back so soon. 2 days later, my rover appears completely offline, meaning I couldn't connect to the onboard computer or the PTZ camera. There was nothing to tell me what went wrong, and I was fearing the worst. The only thing I could do was go and collect the rover. This is what I found. This is the rover here, and this is the PTZ camera, snapped off a good 3 to 4 meters away. You can see here the GPS bracket has also been snapped off. The solar panels are cracked, and that makes sense why something. And all the fishing line that holds the solar panels straight has been broken. Now it's starting to make more sense why I couldn't connect to the rover. But why did this happen? This can be pinned down to one flaw of my rover design: the solar panels. Although I have no footage to prove it, the evidence leads me to believe that a very strong gust of wind caught underneath the 16 kg rover's solar panels and flipped the rover up and onto its back, bending and cracking the solar cells, snapping the GPS bracket, bending the aluminium extrusion, and catapulting the PTZ camera off into the distance when it would have fallen back down. This was the reason why on windy days I would face the rover's back directly into the wind and then shut it down so that it would be harder for the wind to get under the solar panels and flip the rover up. But with me not being able to move the rover, there was nothing I could do. But as for what caused the rover to stop driving in the first place, I can only really guess. After driving back home and putting the rover back into the garage, soon after it unexpectedly started driving again, trying to head off back into the mine to continue its mission. My best guess as to what caused this is that this suspected loose wire connection may have vibrated back into a decent enough connection for the rover to drive, but I can only speculate. Which leads me to where I am now, a whole 3 years from the start of this project. I've grown so much as a person and learned so much from everything I've done, and I'm really proud of what I and the rover have achieved. Thank you so much for watching, and leave a like and sub.